Today's talk has two parts. First, I will introduce you to the history of medicine as a discipline and make an argument for why I did not waste 8 years of my life pursuing a PhD in history. Then, I will use short vignettes illustrating the development of modern nutrition to explain 3 contemporary myths drawn from the longer list set forth in the Nutrition Myths and Healthy Dietary Advice in Clinical Practice article from our colleagues Lenard I, Mary Carol Mazza, and Sean Lucan in Family Medicine. One thing I want you to walk away with today is the observation that one generation's scientific fact is often the next generation's scientific myth. So, the outline of the talk is why not history of medicine, then we will cover nutrition in the past, and 3 myths: quantitative nutrition and counting calories, heart health versus satiety, and fiber as the solution to civilization. To begin, why study the history of medicine? I entered this field out of sheer curiosity about the way things were back then. What kind of diseases did people get? How did they treat themselves and each other? How did they explain what was happening to and inside a body with cancer, phthisis, or ague? This is a curiosity rooted in my own physicality and personal experiences of what it means to have a body. This is the level on which I have found most people are interested in the history of medicine. We are comfortable in our bodies until pregnancy, disability, or disease occurs, and then our relationship to ourselves changes. We can learn a lot about our embodied selves, both individually and collectively, through illness. This accounts for the popularity of what has recently been called sick lit, memoirs by authors struggling with chronic disease, disability, or addiction. Why not turn that critical lens on people and societies in the past? What can we learn about them through their experiences of pain, illness, birth, and death? Now, a certain tension exists within the discipline of history over how similar people in the past were compared to us now. Is the past a foreign country, as British author L.P. Harley wrote? I tend to be a moderate on this issue. If historical actors were completely different from ourselves, then there would be no hope of understanding them, and studying history would be an exercise in futility. If people in the past were just like us, then it would be easy to take lessons from the past and apply them to the present. However, I think it is obvious that we inhabit a different world than 100 or even 50 years ago. Improved technology is the most obvious example, but gender and race relations have changed too. Even the very nature with which we interact in the clinic and in our daily lives is different. Think of viruses, DNA mutations, and antibiotic resistance. A century ago, those concepts did not exist. People made sense of the world the best they could. As a historian, therefore, I find the past different, but understandable. Because the past is different, research can discover things about it. And because the past is understandable, that research is interesting, and it may even tell us something about the present by way of comparison. What does this mean for understanding medicine in history? Let me talk theory first and practicality second. One theoretical approach is to take the knowledge we have today and apply it to the past. This methodology assumes that we understand the natural world the way it really is. Thus, when historical actors write about phthisis or ague, we argue that they meant tuberculosis or malaria. So when Dr. Austin Flint has a paper entitled Acute Tuberculosis Supervening on Phthisis, we know he meant tuberculosis. or from this old Danish proverb that joy is like the ague, one day, good day between two bad ones. This desire to correct historical actors is the impetus behind the genre I like to call medical history mystery, in which authors, usually physicians, try to figure out why Ludwig van Beethoven went deaf, or they diagnose Emily Bronte with Asperger's syndrome. Such concrete thinking makes comparisons between the past and the present easier, so we discuss whether bubonic or pneumonic plague was responsible for the Black Death epidemic in the 14th century, that Columbus brought syphilis to Europe from the Americas in the 15th century, or that well into the 19th century it is likely that 100% of some urban populations was colonized with Mycoplasma tuberculosis. However entertaining or intriguing, medical history mysteries are only part of the story, because using today's medical concepts to talk about the past often tells us more about the natural world back then than about the human individuals and societies who inhabited it. Therefore, most historians of medicine these days employ a relativistic point of view. We ask, what did historical actors think was going on, and what does that tell us about their body concepts, their social structures, or their worldview? Take the Black Death. How and how widely it spread reveals a connected medieval world that, if not exactly global, already spanned Eurasia from China to the British Isles, and possibly to the west coast of Africa. We find explanations rooted in religion and astrology. Massive morbidity and mortality not only introduced a fascination with death that inspired amazing art, but it also decreased the available labor force and increased wages. In other words, this infectious disease that we could treat medically also had economic and political side effects. In fact, epidemics have been a common lens for medical historians to study the social structures and cultural values such as self versus other, citizen versus immigrant, from cholera in the 19th century to Ebola in the 21st century. Finally, there's the question of practicality. Few historians of medicine are interested in discovering forgotten diagnostic methods or therapies to help treat patients, and that's not just because few of them are clinicians anymore. It is not primarily facts that make history good and useful to practitioners of today's scientific modern medicine. Instead, I would argue that it is precisely this relativistic perspective that medical humanities disciplines such as history offers. Evidence-based medicine trades in meta-analyses and statistics, but it is practiced by human beings for individual patients who live and work in complex social contexts, as this one from Sir William Osler reminds us. The good physician treats the disease. The great physician treats the patient who has the disease. Now that cultural competency is becoming passé and everyone is talking about structural competency, I wonder if in a generation we will say, the greatest physician treats the society that produces the disease. For my part, studying the history of medicine has made me a more humble clinician, and I have learned that just because we do something a certain way now, does not mean it is the best or only way to do it. The new is not necessarily better than the old. So let's look for a moment at the way they used to do it. Most of my research over the last 5 years has dealt with nutrition in Germany in the 19th and early 20th centuries. I am particularly interested in the creation and circulation of scientific ideas. My dissertation concerned ideas about food and bodies in Germany around World War I. The first part covered the development of modern scientific nutrition and the interactions between mainstream and alternative nutrition experts. The second part of my dissertation examined how their advice changed due to the stresses of the Allied hunger blockade on Central Europe during and after World War I. you didn't know, the British led a trade embargo against Germany and Austria that lasted from the start of the conflict in August 1914 until the signing of the Paris Peace Treaty at Versailles in June 1919. It was illegal under international law at the time because it targeted civilians. German submarines torpedoing passenger ships was unlawful for the same reason. At any rate, I argue that experiences of food rations and soup kitchens were a major catalyst in Germans' growing sense that they were a connected biopolitical entity from the level of molecular nutrition through the culture of the family dinner table, all the way up to international agripolitics. This is what I call the telescopic body, and I've spoken about it before at the University of Illinois College of Medicine Spring Research Symposium, among other places. Germany is an excellent place to look for the history of nutrition because its university-based, government-supported research institutes were prolific and influential in Western science, especially in the 19th century. Already in 1827, the major macromolecular groups of carbohydrates, protein, and fats had been differentiated and named. Actually, that was by an Englishman. But in the 1860s in Munich, a group of scientists began to define human physiology chemically and mathematically. They built larger and smaller respirators to measure basal metabolic rates of experimental men and dogs. They also calculated the number of calories required for various kinds of physical exertion. They and other researchers used bomb calorimeters to determine the number of calories in various foodstuffs. This was the start of reductionism in modern scientific nutrition, the drive to break down foodstuffs into ever more and ever smaller component parts, and to count or otherwise measure them. Let's remind ourselves of some basic physics here. 1 kilocalorie is the amount of energy necessary to raise 1 kilogram of water from 15 to 16 degrees Celsius at sea level, and 1 food calorie equals 1 of these thermodynamic kilocalories. Emphasizing a bioenergetics approach to metabolism, one of these German researchers, Max Rubner, then elucidated the isodynamic law. He showed that 1 calorie contains the same amount of energy whether it comes from carbohydrate, fat, or protein, but that the energy contents of each of these macromolecules differs by its mass. Thus, proteins and carbohydrates produce 4.1 kilocalories per gram, while fat generates 9.3 kilocalories per gram, all values that nutritionists still use today. Incidentally, alcohol has 7 kilocalories per gram, where, again, 1 kilocalorie equals 1 so-called food calorie. The apparent precision of this kind of quantitative physiology was very appealing in the 19th and early 20th centuries. For one thing, the requirement that output match input fit one contemporary metaphor of the body as an internal combustion engine that burned food for fuel. In an age of rapid modernization and industrialization, this was man as machine. For another thing, if nutrition could be reduced to so and so many calories of a finite number of macromolecules, then it would be easy to make dietary recommendations for the general public, to determine rations for the military, and even to set wages for breadwinners. This idea was expressed as the VOIT standard, named for Carl Voigt, one of the Munich researchers. He determined that a 70 kilogram man doing average work required 500 grams of carbohydrates, 118 grams of protein, and 56 grams of fat for a total of 3,100 calories per day. Actually, it was sometimes called the VOIT minimum because he postulated that a laboring man should consume at least that much protein every day to maintain his muscle mass. Women required 75 to 80% of these amounts. growing youth and physical laborers more, children and intellectual laborers less. You can see from this teaching poster from the 1920s, which represents the daily nutritional needs of persons of various ages and body masses as fractions of cold briquettes. These numbers regularly appeared in nutritional advice directed to physicians and laypeople, usually calibrated to the 70-kilogram standard man. So there appeared to be a single nutrition recommendation. But the majority of German bodies were younger, older, female, heavier, more sedate. I don't know if I would go so far as to declare these numbers myths, because they have a certain validity. But almost immediately after the Munich group announced their findings, both American and European reform nutritionists who favored low or no meat diets published results from their own studies to refute such a high protein minimum. Meanwhile, leaders of blue-collar unions argued that employers should pay their members higher wages so that workers could afford to purchase enough meat to attain the amount of nutrition that science told them they needed. Historians characterize the 1910s and 1920s as a watershed moment in the development of modern nutrition. They typically talk about a shift from quantitative nutrition to qualitative nutrition. But in my research, it quickly became evident that by the late 19th century, there were already two major criteria for a healthy diet. One was quantitative, enough calories from assorted macromolecules, while the other consisted of qualitative factors such as a calm dining atmosphere and pleasant aesthetics. At first glance, the advice in the right-hand column seems quaint, but don't make the assumption that the scientific experts, read men, were making the numbers-based recommendations on the left, and that the authors of dainty housewife manuals, read women, were making the soft recommendations on the right. I found all these suggestions in a wide variety of texts. Even internal medicine and clinical dietetics textbooks written by and for physicians and other scientists carried this qualitative advice because the external social environment was thought to influence the internal biological environment as mediated through the nervous system. In 1912, Casimir Funk published the word vitalamine for the first time. Funk's research at the Pasteur Institute in Paris contributed to a growing body of knowledge about micronutrients that heralded a new kind of qualitative nutrition, in which the kind of food and how it was prepared became important. Essentially, what happened was that mainstream researchers confirmed in the laboratory what alternative researchers had been saying for a generation, based on a combination of philosophy and science. One major change was encouraging people to eat more raw fruits and vegetables, or to steam and braise them rather than boiling them and pouring off the nutrients with the wastewater. This so-called newer knowledge of nutrition was not accepted overnight, due in part to resistance from mainstream nutritional scientists who still believed in the myth that uncooked vegetables were indigestible. Time lag to acceptance is common and expected in the history of scientific ideas. I propose that reception of qualitative nutrition was further delayed due to the fairly unique and unexpected occurrence of food rationing during World War I that was built around qualities that were easy to measure and count, namely calories, liters, and grams. Nevertheless, we can see that the cutting edge of nutritional science was already becoming recognizable 1 century ago. Now, in some ways, we continue to treat the body as an engine and nutrition as a mathematical conundrum. The nutrition facts label is a prime example. It is a natural result of the massive food industry, which manufactures prepackaged, ready-made products with supplemental nutrients and preservatives for long shelf lives. How else can consumers know what is in their food? Isn't the nutrition label a triumph of the FDA and modern regulation? Maybe. Even leaving aside the ways in which manufacturers manipulate labels, for instance, by giving high-calorie foods small serving sizes so that the calories per serving appears to be a satisfactorily low number, slow food and whole food activists protest that we should not have to read a label to figure out what we're eating. But even if we stay within the realm of practicality, which dictates that most of us have to get the majority of our food from grocery stores, and that packaged foods save time and keep better than fresh ones, the nutrition label commits the same one-size-fits-all fallacy that the original dietary experts did, which is focusing the greatest attention on the average or standard eater. The fact is that there is no single diet that will meet the physiological needs of a healthy 14-year-old boy, a type 1 diabetic, a pregnant woman, a man with ulcerative colitis, a type 2 diabetic, a patient on Coumadin, and someone who is lactose intolerant. We medical practitioners know these things, but the public does not hear often enough from us about these nuances. This brings us to current nutrition myth number 1, that maintaining a 3,500 calorie energy deficit per week will result in a 1 pound or 0.45 kilogram weight loss per week. This is the 4th myth covered in the lesser Mazza and Lucan article, and it was easy to confirm with a quick search online. Here's just one example from a website on fitness. This diet requires that you burn and or cut a total of 3,500 calories. And this one from a website dedicated to health. Find out how to drop 2 pounds a week by trimming 500 calories each day for a total of 3,500 calories a week. So here's the myth, and this is the reality. Lesser and co-authors use a weight loss algorithm from the National Institutes of Health that suggests a more realistic expectation is only 20% of the claim. The problem with this belief is that it simplifies the complex mechanisms of basal metabolism and homeostasis. A linear relationship between calorie deficit and weight loss is not sustainable, even though daily calorie requirement decreases with body mass, because the body will attempt to return to its set point by increasing hunger signals and slowing metabolism. The body is not, in fact, a machine that burns food for fuel, and yo-yo dieting is at least as much the fault of normal biology as it is of faulty willpower. Let's remind ourselves of the underlying physiological mechanisms. This is a highly simplified diagram depicting the two main appetite hormones, ghrelin and leptin, whose primary targets are neurons in the hypothalamus. Ghrelin is a neuroendocrine hormone primarily secreted from the fundus of the stomach, and it stimulates hunger. Now, if you need a mnemonic to help you remember the difference, remember the gremlins and don't feed them after midnight. Now, the satiety hormone leptin is primarily produced by adipocytes, so you might think that increased body fat would work by negative feedback to reduce hunger and eating. And it does, to a certain extent. But excess leptin production eventually leads to leptin resistance, along pathways similar to those of insulin resistance. At some point, an overfed body no longer feels full, and an insulin-resistant body is relatively starving, insofar as peripheral tissues are no longer able to take up as much glucose from the blood. There is also interesting work being done now on glucagon-like peptide, or GLP-1, which is produced by the fundus of the stomach and which stimulates the brain's reward centers at the anticipation of eating and after eating. GLP-1 receptor agonists like exenatide and liraglutide are currently approved by the FDA for both type 2 diabetes and as adjuncts in the treatment of obesity. Finally, I'll mention cholecystokinin. CCK secretion is stimulated by fat and signals satiety in the hypothalamus and by slowing gastric transit time. As a matter of fact, observers in Germany during and after World War I had already noticed that continuous calorie restriction does not lead to continuous weight loss. Thanks to the Allied trade embargo, less food was being imported and less food was being produced due to lack of imported fodder and to resources such as fertilizer and manpower being diverted from farms to the war effort. Less than 1 year into the conflict, bread rationing was implemented in Germany. Soon, meat, potatoes, milk, and many other things could only be purchased in limited amounts with coupons, or on the black market at exorbitant prices. Following the nutrition norms established by scientists like those in Munich 20 to 40 years earlier, various government offices set rations as X number of calories for persons of various ages and occupations. They did not take into account sex or weight, although they did develop a system for special populations such as pregnant and lactating women. This table represents general rations in the big city of Dresden in 1918. You can see at the top the age ranges, with everyone 8 years and older receiving the same rations. At the bottom, you can see that the maximum number of daily ration calories was clearly going to be inadequate for most persons. Granted, some food could still be purchased on the free market, but it tended to be low-calorie items such as fruits and vegetables, whose availability fluctuated with the seasons. Germans were not used to eating so few calories and such a plant-heavy diet. Alternative nutritionists thought this was great, and they received some affirmation in the form of the obfuscations and half-truths that the physicians loyal to the government told, that behind the blockade there was enough food to go around, that rates of diabetes, heart disease, and even preeclampsia were decreasing, and that Germans were losing their weight, but not their morale. A pair of professors at the University of Leipzig seized on this natural experiment and conducted a food journal and monthly weigh-in study that found a nonlinear relationship between weight loss and food needs. If a standard 70-kilogram man lost 10 kilos, which is 22 pounds or 14.3% of his body mass, his food requirements decreased by 12.5%. Over the ensuing months, as the food supply improved, study participants' weights rebounded. However, their morale did not. The professors found that between rations, the free market, the black market, and home gardens, Germans were getting enough calories for the work they were doing. But the calories came predominantly from carbohydrates. Civilians on the home front missed feeling full because they were not eating enough protein or nearly as much fat as they were used to, or that was necessary for robust mental and physical performance. An Australian woman living in Leipzig wrote to her sister near the end of the conflict, "Most people complain of being undernourished. Probably the average German, accustomed to very fatty food and much beer, feels the change more than I do. You see, we have neither meat, fat, milk, oil, nor fruit. It is deadly monotonous, but I can't say that I feel underfed. I am certainly always hungry, but I never felt better or fitter in my life, and I can't understand why so few people seem able to adapt themselves to the same regime." Historian Avner Offner opined much later, the German people were often cold and hungry. But whatever their complaints, Germany did not starve. The hunger blockade not only reinforced Germans' predilection for cooking with fat, it also demonstrated the limits of RUBNER'S isodynamic law. A calorie is not a calorie is not a calorie. It matters whether it comes from an easily digested cracker or from a hunk of meat. Germans' subjective experiences at the dinner table encouraged scientists like Otto Kestner to revisit the idea of digestibility. He argued that mainstream experts' one-sided focus on quantitative nutrition missed the point. Human beings don't eat for calories or macromolecules. They eat to feel full. Kestner pointed out that, with the exception of some specialty weight loss clinics, few physicians instructed their patients to count calories. Instead, most made more general dietary recommendations on the basis of food items and meals. And besides, physiology was finally in a position to quantify the subjective feeling of satiety, he said. Although Kestner was investigating qualitative nutrition, he could not escape the epistemological need to quantify in the laboratory, because the ability to reduce his evidence to numbers was a marker of scientific legitimacy, and I think you'd agree that it still is. You are probably aware that the science of digestive physiology extends back at least to the 1820s with William Beaumont and Alexis St. Martin, who had a stomach fistula from a gunshot wound. Thereafter, researchers in Europe and North America determined how long it took the stomach to digest different amounts of various foods. By the late 1800s, the standard reference in Germany was a set of tables compiled by FRANZ, which divided foods into categories by ease of digestion. Liquids were easy to digest, while heavy, fatty foods were hard to digest. And as an aside, the foods on the left were the ones prescribed to children and convalescents, and as a patient's condition improved, their diet was advanced from left to right. These physiologists were studying the mechanics of gastric motility. Otto Kestner's contribution was to make gastric emptying a quantifiable marker for the subjective feeling of fullness. The faster a food exited the stomach and/or moved through the small intestine, the sooner the eater felt hungry again. Satiety for him was synonymous with slow gastrointestinal motility. This is what scientists already knew in 1919. The factors that decrease gastric motility include solid food as opposed to liquids, a medium-sized meal because a very small one will exit the stomach quickly, and a large one will activate stretch receptors to also leave the stomach fairly quickly. Fat decreases gastric motility, as does hydrochloride, which is stimulated by protein, and then also to a certain extent carbohydrates decrease both gastric and intestinal motility. Therefore, amassing all of this evidence, Kestner concluded that this is the physiologically perfect meal. Begin with bouillon to stimulate the gastric juices, have 50 grams of meat for protein to digest slowly in the stomach, and add to that 100 grams of potatoes for the complex carbs, and then finish with a sweet dessert to digest slowly in the small intestine. This is the stereotypical Central European main midday meal. As Kestner says, that is the typical peacetime midday meal. Appetite and satiety have guided us beautifully. Kestner wasn't just congratulating Central European culture for having developed a so-called perfect meal according to what was then cutting-edge science. He was also making a political statement about the trade embargo and the punishments decreed in the Versailles Treaty. If Germany was sending France a large percentage of its agricultural livestock, and if it was simultaneously prohibited from importing meat from Australia or the Americas, then its population would continue to suffer under and malnutrition. This is science, politics, and economics coming together in the laboratory and on the kitchen tables of ordinary Germans. We can now address current nutrition myth number 2, that dietary fat is detrimental to vascular health and that it leads to obesity. It is the second myth that Lesser et al. Address in the American Family Physician article, and they have actually rolled two things into one. One is whether dietary fats, and of which kinds, have negative effects on cardiometabolic disease and mortality. The other is whether low-fat diets are the only way to produce and maintain weight loss. By now you must have guessed that fat and satiety have something to do with it, but let's begin at the beginning, with the diet-heart hypothesis. Here is the myths on the left, and the realities that I'm going to argue for on the right. So the diet-heart hypothesis was the brainchild of University of Minnesota physiologist Ancel Keys. Beginning in the late 1940s, Keys collected statistics about diet, health, and mortality from around the world. In particular, he is known for the 7 countries study, a prospective cohort study whose strength was its relatively large numbers and long follow-up period. Keys concluded that there is a direct relationship between saturated fat intake, hyperlipidemia, and coronary heart disease, and he vigorously promoted a low-fat Mediterranean diet. The public ate this up, and cookbooks like this one were extremely popular. The media christened him Mr. Cholesterol, although in reality he was more concerned about saturated fats. Critics then and since have pointed out that statistical correlation is not biological causation. Nevertheless, in the 1960s, the American Heart Association decided that it was willing to forego scientific certainty for the high probability that Americans were eating themselves to death with a Western diet rich in animal products and saturated fats, and it endorsed the diet-heart hypothesis. An NIH consensus conference agreed in 1984. This manifested itself in clinical guidelines on HDL and LDL levels, and in public education campaigns about good cholesterol versus bad cholesterol. People began to cut cholesterol from their diets, both for better heart health and for weight loss or control. Ironically enough, the cincher to the diet-heart hypothesis may have been the development of a drug class, HMG co-reductase inhibitors. Statins became a big pharma blockbuster in the 1980s and 1990s after large randomized controlled blinded studies such as the Scandinavian simvastatin survival study, found a reduction in major coronary events, in revascularization procedures, in coronary deaths, and in all-cause mortality. In 2002, the old ATP3 guideline canonized cholesterol reduction under certain limits in order to reduce the risk of cardiovascular disease. Then, in November 2013, the new ACC-AHA statin guidelines obviated a linear relationship between hypercholesterolemia and cardiovascular risk. So, these are the 4 groups of patients who need a statin: those with atherosclerotic cardiovascular disease, an elevated LDL, diabetics with an LDL over 70, and non-diabetics with an estimated 10-year risk over 7.5%. And then these guidelines came with certain do's and don'ts. Do use the maximum tolerated dose of a statin, but do not titrate to LDL level. In fact, do not even recheck LDL level after starting a patient on a statin. And don't start one on a patient over 75 years old. Now, Les Van greeted the simultaneous lifestyle working group recommendations. These familiar dietary patterns and activity levels are directed primarily at patients with at least one risk factor for cardiovascular disease, such as hyperlipidemia, hypertension, or diabetes, independent, mind you, of weight. And they apply secondarily to all adults as good lifestyle advice. These guidelines focus on saturated and trans fats, not cholesterol, which is why early reporting suggests that later this year the USDA and U.S. Department of Health and Human Services will finally drop cholesterol from their national nutrition guidelines and focus on saturated fats, because evidence is accumulating that dietary cholesterol does not affect cardiovascular health. Let the egg industry rejoice. However, there is also evidence that saturated fat does not have the detrimental effects that have been attributed to it. Amount of total LDL appears to be less predictive of cardiovascular disease risk than the number of particles or their size. Having many small, dense LDL particles is linked to greater cardiovascular disease risk than having fewer, low and very low density particles. But clinical guidelines have been structured around LDL as a lump sum. As for dietary fat intake, saturated fat raises both low density LDL and VHDL to clear it. By contrast, carbohydrates, especially simple and refined carbs, increase high density LDL and triglycerides. A number of newer prospective studies and meta-analyses, including at least 2 Cochrane studies in the last 5 years, have shown that the source of saturated dietary fat matters too. Saturated fat from dairy may actually be protective, whereas saturated fat from meat and processed foods is harmful. The citations for these studies are in the endnotes to the Mazza and Lucan article if you are interested. These 3 authors go further to argue that low-fat diets have contributed to the obesity epidemic. In the wake of the diet heart hypothesis and Framingham, many Americans have attempted to reform their diets, dutifully switching from butter to margarine and exchanging eggs and bacon for a bowl of cereal with low-fat milk in the morning. While it makes a kind of intuitive sense that dietary fat would become bodily fat, it is also true that excess carbohydrates are converted into adipose stores and contribute to insulin resistance. By increasing their carbohydrate intake, Americans not only potentially increased their susceptibility to cardiovascular disease, they lost the satiating benefits of protein and fat, as the Germans learned almost a century ago. Therefore, Lesser et al. Cite a number of meta-analyses showing that diets higher in fat produce and sustain as much or more weight loss than lower fat or calorie-restricted ones, and it is hypothesized that this is by virtue of the satiating effect of protein and fat. My research covers the time period in which fiber's importance in a well-rounded diet was recognized. Fiber is the undigestible part of plant foods. And remember that before the acceptance of vitamins and qualitative nutrition in the early 1900s, the reigning digestive physiology paradigm was of the body as a machine with a combustion engine. Under this paradigm, food that could not be completely digested represented wasted money and calories. For instance, mainstream nutritionists commonly recommended fruits and vegetables be boiled or otherwise cooked. Probably my favorite quotation is this one, from a food chemist who worked for the canning industry in the first half of the 20th century. He said, as for cooking, vegetables must almost always be pre-boiled. I would certainly not want to be a guest where unboiled cabbage, asparagus, spinach, etc. were set before me, because I am not enough of a barbarian in taste. The way food was prepared was not just tradition or science, but cultural too, and civilized people cooked their vegetables. By the way, note the date, which was a full 10 years after Casimir Funk published the word vitalamine for the first time. It took 15 years for the newer qualitative nutrition paradigm to replace the older quantitative one. And I certainly don't fault Serger for his opinion, because change takes time. Civilized people cooked their vegetables, but there was something else about people with culture. They suffered from so-called diseases of civilization, like diabetes, obesity, heart disease, and constipation. This issue is best reflected in the bread wars. Most Europeans and Americans at this time preferred white baked goods to dark bread and rolls. Reformists complained that people were abandoning the healthy habits of their grandparents, but mainstream nutritionists pointed out that whole grains are not fully digestible. Scientists actually performed comparative microscopic analyses of stool samples to prove that a diet high in roughage produced larger and more bulky stools, evidence that a so-called traditional diet exceeded the capabilities of the average human digestive tract. Is it any wonder consumers preferred refined white bread? And yet, at the same time, there was practically an epidemic of constipation and diverticulitis, with quacks peddling a variety of laxatives and enemas, and surgeons offering to remove patients' colons to cure them of their irregular bowel habits and of toxin contamination from their leaky guts. During World War I, the food most impacted by the trade embargo and subsequent rationing system was bread. Needing to stretch smaller harvests and imports, authorities decreed that grain be milled at higher percentages. Instead of a refined 65% of white grain and flour, war bread consisted of 94% rye, that is to say, almost whole grain, with added potato or barley flour to stretch the dough. However, special dispensation was sometimes made for children or patients suffering from abdominal complaints. They could apply for ration coupons for refined wheat baked goods, on the theory that their delicate digestive systems could not handle the tough war bread. Reformists then tried to tease apart the poor quality of wartime flour and baking conditions from a well-ground whole grain flour that used the whole germ, endosperm, and bran. As vitamins became accepted over the course of the 1920s, more mainstream experts were willing to trade the relative indigestibility of bran and fresh produce for their nutritional value, primarily vitamins A, B, and C. There was also the added benefit of bran and fiber in preventing constipation. I would like to be able to tell you that there followed a golden age in which consumers gladly embraced whole grains and uncooked fruits and vegetables, but even the Nazis were not able to legislate healthy eating habits. After the disaster that was the food supply during World War I, many Germans embraced the ideal of food autarky, meaning Germany ought to be able to produce all the food it needed to consume. This idea drove much of Nazi domestic and foreign policy in the 1930s and 1940s. So choosing whole grain rye bread over refined imported wheat rolls was a question of politics as well as one of taste or economics. Unfortunately, the idea that any modern industrialized nation could exist independent of international trade had been unrealized since the late 1800s. On top of that, already in the 1930s, chemists had figured out how to supplement foods with vitamins. This reopened the question of what a healthy food is. Can margarine be as healthy as butter if it has added vitamin A? Can white bread be as healthy as whole wheat if it has added vitamins and fiber? The authors of the AFP article argue that we should make a distinction between dietary fiber as found in natural whole foods and functional fiber as found in processed foods. Artificial fibers have not been shown to be beneficial and may in fact be detrimental if they interfere with the absorption of nutrients. By contrast, natural dietary fiber in whole foods contributes to overall health and well-being, including less insulin resistance and less constipation. In conclusion, one generation's scientific fact is frequently the next generation's scientific myth. I won't say this is due to progress, because the history of medicine shows us that every new development brings with it some improvement, but also questions about cost, side effects, and unintended consequences. Nevertheless, I will say the time lag of scientific change is due to the time necessary for information to travel, for laboratory results to be confirmed, and for paradigms to shift. In early 20th century Germany, experiences of the hunger blockade during and after World War I shaped the development of modern nutrition. They learned that quantitative nutrition that counts calories of the three major macromolecules does not suffice. A healthy diet needs to include a variety of unprocessed foods to provide vitamins, minerals, and fiber. In the 21st century, we are learning that dietary fat is neither expendable nor entirely evil. Rather, it is necessary for satiety, should not be replaced by simple carbohydrates, and is not the only culprit in heart disease. Here are some take-home points for you. In addition to this idea about generational change in fact and myth, the general pattern of mainstream nutrition has been toward reductionist, increasingly quantified explanations and recommendations. There has always been an undercurrent of alternative advice based on more qualitative factors such as wholesomeness or satiety. The vitamin is 100 years old, and the calorie is 150 years old. It is fair to ask whether we should base our current recommendations on century-old results because they are true and have withstood the test of time, or whether our national nutritional paradigm should shift away from calories in versus calories out, given what we now know about the complex hormonal regulation of hunger and satiety. As healthcare practitioners, we have dedicated ourselves to lifelong learning. I hope not just learning new facts, but also absorbing critical ways of examining the science behind them and the politics and economics of their application. We are not automata programmed to perpetuate the status quo, or at least medicine's best and brightest should not be. Lifelong learning means lifelong thinking, not mere regurgitation. And so it is with no small irony that, in dutiful historian of medicine fashion, I leave you with Hippocrates' first aphorism, translated from the original Greek into Latin. Ars longa, vita brevis. Art is long, life is short. I hope you have enjoyed learning a little bit about the art of medicine today. Thank you.